Good morning, good afternoon, good evening, everyone. It's me, Bernard, your favorite GeoGebra teacher, and today I'm here to use GeoGebra to explain certain concepts in probability. And in this case, we'll be, we'll focus on binomial distribution. Focus on binomial distribution. Now, when you say a binomial distribution is a probability distribution that models the number of successes in a fixed number of independent experiments or trials, where each trial has only two possible outcomes, a success or a failure. Now, when it comes to a binomial distribution, we deal with n, and in this case, it is the number, a fixed number of trials. And you perform the experiment of a set of at a set of number of times, and then we deal with you see the success or failure of a particular event happening with respect to the n number of times. So in this case, let's take a question. So a question where we say a feather is rolled 6 times. A feather is rolled 6 times. Now we know a die has what? A die has about 6 what's it called? 6 possibilities, in the sense that there's a possibility where you can get 1, 2, 3, 4, 5, 6. You get it. And in this case, it is rolled 6 times. So our n here will be 6 because it is rolled 6 times. Good. As I said earlier, it has a possibility of it has 6 sets of numbers. So it has each number has a possibility of appearing 6 times. So that will be 1/6. Good. So now, what does our question demand? Our question is demanding us to said, what is the probability of getting the number 2 exactly 3 times? The number 2 exactly 3 times. So when we come here, possibility of getting the number 2 exactly 6 times, 3 times. Now, this is the value. This is the probability of what getting the number 2 when it's rolled 3 times. Get it. And then let's go to the next question, which is a fair die is tossed 4 times. So in this case, our n will be what? 4. And as I said, we will still maintain the probability that which is 1/6. That is each number or each variable having a possibility of happening 1/6 times. A fair die is tossed 4 times. What's the probability of getting the number 5 at most 2 times? So possibility of getting the number 5 at most 2 times. So now, so we want the number 5 at most 2 times. That means it should start from what? 0. It should be between 0 and 2. You get it? Inclusive. Which will be what? 0.9838. So you can see that the GeoGebra allows us to easily sum the possibilities where it will not happen, where it will happen 1 time, and then where it will happen 2 times. Okay, so this is basically how you can use GeoGebra to understand the concept of binomial distribution. As I said earlier, the n here is the number of times the variable the die is being rolled, and then the p here is the possibility of each number on the die to happen once. And in this case, this is where we make our mathematical calculations. All right, so now we'll move to the the aspect of statistics. So in this case, we already have a sheet where we have this as the number of scores students would get after an examination in the EDMA 402. So these are the number of scores where one student gets 10, another student gets 11 over 100, another student 14 over 100, 13 over 100, and so on. And in this case, we are going to plot this on a histogram. I'm going to plot this on a histogram. So the first thing, so you come here, you know that a histogram is a one variable analysis. And in this case, we're analyzing everything. So go to a one variable analysis. You can see the list of values here. Then we analyze. Good. So when we analyze, we find out that we can determine the mean of the data set, the variance, the standard deviation. That is if our data is a population, and then the standard deviation if our data is a sample. That is a sample. We've taken a sample out of what we have. So in this case, you can find the minimum, our first quartile, our median, our third quartile, and our maximum value. So you can see our minimum value is 6, our maximum value is 19. Find out that our median is 12.5. Our first quartile is 10.5, and our third quartile is what? 15. Good. So now this is a graphical representation of the data set we have using histogram. So in this case, you can easily determine the standard deviation of the data set. And then we can also easily determine the mean of the data set. And as shown here, we have 12 number of 12 elements here. Yes, it's yeah. So this is a graphical representation of the data sets that we have here. So in this case, we can if we can change it, if you want it to be, let's say, a bar chart. You get it. So you also have this same data being represented by a bar chart. A bar chart. Then if you want a stem and leaf plot too, you can get it here. Good. And in this case, we have this one happening. That is one having it like things 10, 10, 11, 11, 12, 13, 14, 14, 16, 18, and 19. Okay. So this is what we have for today. Today, what have we been able to learn? We have been able to learn that a binomial distribution is a distribution that models the number of successes in a fixed number of independent experiments or trials, where each trial has only two possible outcomes, which is a success and a failure. And in this case, we have been able to graphically represent our data sets for us to easily understand and get the meaning of the values that we have here. So this is where I bring my presentation to an end. Enjoy your day. I'll meet you another time. Bye.